Good morning, afternoon, evening to you, wherever you are in the world. Today we are addressing a common challenge in many space shooter games: switching bullets. There are numerous ways to tackle this issue, but in this lesson, we'll demonstrate a solution using the factory pattern and inheritance. As Godot employs object-oriented programming, we can harness its capabilities to create elegant code that effectively resolve typical problems. Design patterns and object-oriented programming are vital tools in software development that enhance code quality, maintainability, and scalability. Design patterns are reusable solutions to common problems, providing developers with tested structures and techniques that promote efficient problem solving. OOP, with its focus on abstraction, encapsulation, inheritance, and polymorphism, enables modular and structured code organization. By utilizing design patterns and OOP principles, developers can create more organized, readable, and reusable code, reducing the complexity of projects and making them easier to maintain and extend. These approaches facilitate collaboration among developers, ensuring that code bases remain consistent, adaptable, and robust over time. Employing design patterns and OOP in software development ultimately leads to more efficient, flexible, and sustainable applications. In today's lesson, we are going to explore factory pattern and inheritance. A factory pattern is a design pattern that centralizes object creation by delegating it to a separate entity called a factory. This approach promotes flexibility and extensibility by allowing the creation of different object types without modifying the code that uses them. The factory pattern simplifies object instantiation and decouples the client code from the concrete classes, making it easier to add, modify, or remove objects in the system. In today's demo game, we feature 3 bullet types, and their creation process will be delegated to a dedicated bullet factory. Inheritance is a fundamental concept in object-oriented programming, where a new class called the derived or subclass inherits properties and methods from an existing class called the base or superclass. This mechanism promotes code reuse and modularity by allowing shared behavior and attributes to be defined once in a base class and then extended or overridden in derived class as needed. Inheritance enables the creation of hierarchical class structures that can represent complex relationships and promote maintainable, organized code. The game includes 3 distinct bullet types, each extending a base bullet class and incorporating unique features within their respective subclasses. Other topics we are going to briefly discuss in this lesson include Singleton, sprite, and animated sprites. We are going to have dedicated tutorial in the future for these topics. Let's first talk about the project structure. In this case, I always use package by feature approach. This feature and approach encourage modularity, improved maintainability, easier navigation, and enhanced reusability. So if you look at the left-hand side, the main folder is called scenes, and under scenes I have 3 categories. So these represent the features. We have bullets, we have fighter, we have main. In the bullet, I also subdivide them into 3 categories, one for each bullet type. I have arrow, circular, and flame. For fighter, we have only one type, and main means the main scene for this game. I have already set up the project. As you can see, we have dedicated folders for each individual features. Before we get started, I want to first configure the window setting. We go to project settings and come down to window, and I give it width 600 and height 800. And here I also want to make sure the orientation is portrait, because I want this game to be top-down fashion. And we allow them to, the mode is canvas, and we want to keep the ratio. First, create our main scene. In the main scene, we are going to need a background. We call this main, and we add a color rect. So we want to make sure this covers the whole game window. So we come here to the material, then we are going to add a shader. So this shader is going to be the same one we used from last tutorial. So we select the shader, and then we can just copy and paste the code here. If you want to know how to do this shader, you can come to my previous video for more information. So after this, we're going to add a world environment. For this world environment, the purpose of this is we want to enable glow effect. So here, when it comes to the glow settings, we want to make sure the blend mode is additive, and we can leave the rest as is for now. Okay, we save this as main scene and under main folder. Before diving into the actual implementation, let's look at the class diagram for bullet. At the top, you can see it's the base class, which is in charge of movement and also removal when it's off screen. And there are 3 derived classes. The first one is arrow bullet, which has a wave movement. Second one is circular bullet. It just have a regular movement. And the third one is the flame bullet, which has acceleration enabled when it moves. Under bullet, we are going to add a new script. We will call it a bullet. We are going to call it a bullet class and give it a variable speed so that we are able to control the speed. In ready function, we are going to introduce a notifier 2D node so that when screen exited event happens, we are able to call a callback. And in this callback method, we are going to call q.free to remove this bullet from the screen. And in the process method, we are going to change the position of the bullet so that it knows how to move. And now we need to change this node to node 2D, because node 2D has a position property. Now let's implement arrow bullet. So let's come here. We're going to introduce a new thing. We call it, we need a sprite 2D node. So we call this arrow bullet. In here, we need to add a new script. We call it arrow bullet. but it should be underneath bullet arrow. Since we already have a basic bullet defined, we are going to extend the bullet class so that we are able to move the bullet around without duplicating the same logic. Because arrow going to make a wave movement, I'm going to introduce 3 variables to control the wave shape, frequency, and offset. In the ready, we're going to make sure we are pointing this bullet upward, so that is going to move upward. We can simply rotate the bullet by 90 degrees counterclockwise, because we also have some method defined in the superclass. When we want to make sure we also invoke that method. So that's why here we have super dot underscore ready. And in the process method is very, very similar. We want to make sure we invoke the logic from the superclass, and also here we adjust offset, and in line 17 we only change the y value on top of the x value, which was controlled from the superclass. If you want to know how we build this wave movement, you can refer to my previous video as well. Now let's save this as a scene. Bullet arrow. Here we save it, and also here we need to give it a texture. We just have to drag it here, and then we're done with arrow bullet. Now let's move on to create circular bullet. Same thing, we create a new sprite 2D. We call it circular bullet. We need to associate this with a script. We save it under circular folder. So we just have to extend bullet. Here, the only thing we have to do is make sure it's pointing upward. Then we are done the script, and we are going to save this as a scene as well. Circular bullet scene, and under circular folder. Last thing we have to do is drag this circular image to use it as texture. Then we're done circular bullet. Now let's create the last bullet. Since it has animation in it, we're going to use animated sprite 2D. So we come to the right hand side under animation sprite frames. We are going to create a new sprite frames, click into it. From this button, we're going to select the image we want to use for animation. Because we have only one column, like vertical, we should use 1, and horizontal we use 4. Now it knows how to slice this image into 4 horizontal images. We highlight all 4 frames, we add them in. Now, so this will allow this animation player to play through all these frames. And I also want to enable this auto load. So this means when this animation be loaded, and it will start playing right away. And frame rate, I will give it 20. After this is done, we are going to add a script. I will call this flame bullet, and it should be under bullet flame. I will also change this to flame bullet. Let's save this as a scene. Go to flame, save it there, and in the ready function we just follow the regular drill. It's just make sure it calls the super method, and also rotate counterclockwise by 90 degrees. And in the process method, we just keep increasing the speed frame by frame, and so this will give us that acceleration for speed. And the same thing here, we need to make sure this class extend bullets. Next gonna be the fun part. This is the first time we're going to use a design pattern in this demo. So we're going to create a new script. We call it a bullet factory. Its responsibility is to help us to create bullets based on the bullet type. Here we are going to introduce 3 constants that represent each of those 3 bullet types. And we want to make sure based on these types we are able to get an instance. So we're going to use a specific data type, data structure here, which is called hash table in GD script. In other language, a similar data structure might be called hash map. Then the rest of the logic is going to be super simple. We create a new method function here called create bullet. Based on the bullet type, we are trying to find it from the hash table. And once we found it and we call instantiate, then this method will give us an instance of the bullet. So this is how we implement a factory method. So we're going to make this factory a singleton so that we are able to access it anywhere inside the code without first initialize it. So we go to project settings, we go to auto load. Here we need to find that script we want to load as a singleton. So here we're just gonna call it bullet factory, then we add it, then now this singleton is available for us to use. Let's draw the fighter. I'm going to first remove all those bullets, and they will be created dynamically. So I'm going to add a sprite 2D node to represent the fighter. I'm going to give it texture. Okay, then I'm going to change its visibility, and I'm going to come to self-modulate and change the color. Okay, and call it fighter and save it as a scene. Now let's add the orbs to the sides of the fighter. They are animated sprite. We just call this orb, and from the animation we create a new sprite frame and click into it, select the image I want to use. Same thing, should be 1 for vertical, highlight all 4, add them in, and make sure the autoplay is enabled. Here I'm going to use 20 as well. Okay. Looks a little bit big, so I'm gonna scale it to maybe 0.5. Yeah, looks better. I want to, let's save this as a scene. Orb scene, because it's part of the fighter, I will just save it under the same folder. Let's change the name to left orb, And I will duplicate this and use this as the right orb. Okay, and drag it over. Change the scale to 0.5 and flip it so that they appear symmetric around the center of the airplane. Let's add a script to the fighter so that it knows how to fire bullets. Here we are going to first access these two children, which are the left and right orbs. And then we are going to define a few variables so that we know how often we want to fire the bullets. So here the fire time threshold means I only want to fire a bullet every 0.3 seconds. And in the process, this is how we use that value to fire bullets. Here, if the fire time is less than 0, that means we reach the threshold, then we are going to fire. And then here we're going to reset the fire time threshold. Otherwise, we're just going to keep reducing the time. So in the fire bullet method, this is where we're going to use the factory method to create bullets. Here, based on the bullet type, we use the factory method to find the bullet. And the bullet one is will be positioned on top of the left orb. And bullet 2 will be the bullet fired through the air fighter. And the bullet 3 is the bullet for the orb 2, which is on the right hand side of the air jet. Let's add a timer to change the bullet time every once in a while. So I'm going to call it change bullet timer. And this is going to be 4 seconds and auto start. So here we'll just change the bullet type based on its current active bullet type. Once arrow, I'm going to change it to circular. Once circular, I'm going to change it to flame. And then it will go back to arrow so that it will know how to recycle. Let's run this application. So as you can see, it starts firing bullets, and it also knows how to change the bullet type. We have 3 types here, as you can see. Conclude this tutorial by adding trails for the fighter. We're going to add a particle 2D node. So here I'm going to give it maybe 400. Emission type, I'm going to use a sphere. So this is going to be 200 maybe. Let's see. Too big, maybe 20. Yeah, okay. Maybe give it more, maybe 1,000. Yeah, okay. Gravity, I'm gonna give it maybe 30. Okay, change to 80. Too small. 200. Okay. So add it here, then I duplicate it, cut left trail, cut right trail, move it over. Then let's run this one last time. All right, yeah, you got the idea. So we are done, and congratulations on finishing this tutorial and spending time with me. If you haven't subscribed to the channel, please do so. And if you have any questions, leave them in the comment section or go to the Discord. server to ask questions over there. Thank you. I will see you in the next video.